So let's start with how social network analysis started. Okay. If you try and kind of Google social network as a string, or you put social network as a string on any search engine, you're very likely to find web pages that mention social network sites, social media platforms, probably Facebook. You're also very likely to find web pages talking about the social network. You might have watched it. It was a movie which was produced a few years ago, and it's about the story of Facebook, basically. If you haven't seen it, I would recommend you watch it. It's quite interesting, and I think it's also rather well made. Okay, so when we think of social networks now, I think most of us as a first idea or as a first image, what we now see on social media. So social media platforms, Facebook probably, or more contemporary digital platforms. But actually, I still think it's very important to try and remember that social network per se as a label or as an idea predates the digital or predates platforms as we think of them now. And I would like to tell you a very brief story about this image that you see on this line here. This is called a sociogram, and it was, drawn by hand drawn by Jacob Moreno. Jacob Moreno was a psychiatrist and a psychologist back in the 1930s in New York. And he was the first to start using drama as part of therapy, as part of psychological therapy. So back in the 30s, actually already in the 20s, he was contacted by a prison in upstate New York. And they contacted him because they had issues and behavioral issues within the prison. And it was getting very difficult for the prison to keep going. So they asked him to come and try and study what was going on with the prisoners and try and inmates and try and see whether there was anything that could be done to improve the situation. Right, so Moreno went there and he got the inmates to do group activities, group work. So you put them together, he asked them to perform some tasks in groups, and then he observed the relationships that were developing within each group and across the groups. So it was looking at how inmates were behaving together in the space. When I say space, I'm thinking about the geographical space of the prison, but also the social space that in a way had formed within the prison. So the place inhabited by human beings put together and constrained in that geographical space. So what he did was to observe them and then try and group them depending on how they were interacting with one another. Okay, he tried to identify who could stay together, who could live together and work together in a peaceful environment or in the most working environment. Okay, so he reassigned roles and locations in a way to make group life work better. He was then involved in some school project or school activities, again in places and institutions where troubles were going on and where head teachers were not able to sort or improve the situation. So there was a case of a specific girls' school where I think around 15 girls had run away from the school, and it was becoming very difficult to get the school to run. So again, they called him and they asked him to try and see what could be done. And he did the same. He observed what was going on in the groups, and he tried to give them different group tasks or team work to perform to see how they were working together and how groups could be changed in a way that life overall for the school overall could work better. Okay, so what you see there is the representation of relationships within a fourth grade class in 1913 in one of the schools where Moreno went to work. Now let's have a look at it together. So I'll just give you a couple of clues and then I'll ask you a few things about this graph, okay, or sociogram, as Moreno used to label them. So the triangles on the left, mainly on the left, represent each triangle is a boy, okay? And each circle is a girl in the class. Now, can you tell me anything about this sociogram, about this representation? The lines indicate an interaction happening, okay? So if you look at this graph, what do you see? What do you want to tell me? Is there anything that you think is particularly evident or interesting? So you can drop it on the chat, or you can also, switch on the microphone and just say what you're thinking. Anything? Anybody? Okay. So we have Madeleine. Only the group on the left reaches out to the group on the right. So, okay, there is one line going to one of the triangles, to one of the circles. Okay. Shiran is saying, yes, that's right, Madeleine. Yes. Let's try to think of it in terms of the actors, or the actors that are represented by the symbols. So what does that mean? It means that one boy is reaching out to one girl, and he seems to be the only one, right? Okay, and then Shiran is saying, it seems like girls are more likely to interact with the people who is close to them. Oh, wow, Shiran, let me see. It seems like girls, so we're looking at the right side of the sociogram, are more likely to interact with the people who are close to them. So you think there are interactions within girls are slightly more dense. Okay, it might be. I hadn't noticed that, but it might be that the girls' graph is slightly that. I don't think it's self-evident, but there might be that some of them are sending more interactions. Then Alexandra, limited interaction between boys and girls. I think Alexandra is naming probably the most evident characteristic of this graph, right? We do see two groups. We don't see one group where interactions are heavily evenly spread. We see two subgroups forming, very much based on gender, right? Stephen is saying only one boy interacts with one girl, right? So it's kind of reaching out. It's kind of bridging these two groups, right? That boy is sending one interaction. So interacting with that girl, in a way, opens up opportunities, because if you think of it in terms of friendships, so if he starts being friend with that girl, through that girl he might get to know other girls, right? So that is opening up opportunities in different ways. Social capital, if you're familiar with the idea of social capital, so relationships in his network might become more. And Sultan is saying members differ in the number of connections. Some of them form main focal points. So I think Sultan is saying that some of these entities, whether they are triangles or circles, some of them have more connections than others, right? We could say they might be influencers, they might be popular in the classroom, they might be more outgoing, more well-known. Okay, so we start seeing very interesting dynamics, right? I mean, they're very interesting to me. I never know if others find them interesting, but they are. There is one more element that nobody has highlighted in this graph. there is one more thing that is kind of very, very evident. It's easy to see it, even if you don't know anything about network measures, centralities. There is one more thing that we see. Connection between the group of boys does not seem to close as much as the girls. So this is Alexandra. Yeah, this is something that was spotted by someone else before you. Yeah, two girls are isolated from others. Yes. I'm not sure what your name is. I'll call you Titi Kank. Two girls are isolated from the others. Look at the top right. Okay. We have those two girls who seem to be friends with one another. One of them sends a connection to the other, which is a good sign, at least that the one to the right is not totally isolated, right? So at least she has a friend or someone who is connecting to her. But then those two are isolated from the rest of the class. So those are called isolates in a network. And the presence of isolates might indicate an issue depending on what situation or what kind of networks we are studying. In a classroom, two isolates might be an issue, you know, if everybody else is more or less connected, at least based on an attribute like gender, as we see here. So we have girls, all the other girls being connected, at least with others within a group, and all the boys are connected. But then those two members of the class are isolated. So we would want to know why, right? Okay, so this observing them and this network is telling us something about social dynamics and social capital within this class. Okay, great. So this is from the 1930s and it's a classroom. So nothing to do with social networks, nothing to do with the internet. It's all about social relations. Okay, so when we use social network analysis in the context of sociological studies or the social sciences, very often we use it to try and understand social relations with or without digital platforms or across the two domains. And more often we're trying to do it actually using information from offline and online, because now the two are no longer separated, right? Our life is very much a mix of the two, and it's difficult to distinguish our social relations between online and offline. Okay, our offline social relations are very often also a bit online, especially now. They have been for the past couple of years. Okay, so I always like starting with Moreno's story because I think it's fascinating, as I said, but you will find other stories of scholars who started looking at social relations in terms of networks, okay? And then, of course, with the so-called network society or information societies, with the early studies of the internet, we see the idea of social network becoming fundamental, key to try and understand how society has been developing around information technologies. Okay, so let's try to summarize in 3 sentences why we use social network analysis. We use these type of techniques because social relations, structural relations, are often more important for understanding behaviors or social behavior than just focusing on individuals' attributes alone. Okay, like age, gender, values, ideology, income, or any of the demographic informations that we very often collect when we run, for instance, survey investigations to understand dynamics in society. So we do use these attributes, but we use them in the context of relations, okay, of network relations. We combine these as attributes of the entities or the actors that we are studying. We look at social networks as affecting behavior in terms of perceptions, beliefs, and actions. Think of the idea of peer pressure, social contagion. They're all indicator investigating how relationships might have an impact on an individuals or a group's behavior and activities and decision making very often. Something that is very important is that whenever you apply social network analysis, you also have to bear in mind that the graph that you're developing or the image that you're creating is a picture of a specific moment, because social networks are fluid. They may change, and they very often do. So if you think of the relationships within that classroom, within that class, it's very likely that they stay like that for some time, but then something might have happened that it might have disrupted the situation. Think of the prison. Networks were working in certain ways, and they were not working very well. But then when Moreno intervened, he tried to change the way in which these social relations were working, or to exploit the characteristics of the networks that he saw in those environments. Okay, so these are dynamics. So do remember, whatever social network you're mapping, that's an instant, that's a map of a very specific moment in time and space. Okay, and it might become outdated very soon. Okay, so if you want to know more about concept theories and the statistics as well of social network analysis, because in the end, social network analysis is very much based on measurements. Okay, I would recommend you spend some time on Nock and Young, 2008. In the last slide of this presentation, you'll find a full reference and other references of social network analysis as a theory and as a technique. Okay. Now I'm just going to move on with key terminology and key elements when we talk about networks within the social sciences. Remember that depending on the discipline you're working with or within, some of these labels might be slightly different. Okay, so the labels and terminology that I'm using here comes from mainly sociology, broadly social sciences. But then depending on which discipline you're working with, you might see slightly different terminology. Okay, so the basics, very basics. When we have a graph, a network graph, we have some kind of symbols. Very often you have circles, and those circles are called nodes. The nodes are the entities of the network that you're trying to study. Okay, so in the case of Moreno's work and the sociogram that we looked at, the entities were the members of the classroom, the class. Okay, the lines that you see within a network graph are called edges. Okay, and an edge between two nodes indicates that there is a relationship between two entities of that network. Now, edges as relationship may represent very different relationships. Okay, they represent interactions, but these interactions may be anything. It could be, and we will see some of them later, but be very open in thinking about what kind of interactions you might be representing. Okay, what kind of relationship you might be representing. Now we're going to see a few types of networks, but just bear in mind there are many more. I'm just going to talk about some basic typology, but think of it as much more extended than what we are talking about today. So the first very kind of easy to understand type of network is that of directed networks. Okay, so if you think of networks, network graphs, whenever you see that your edges have an arrow, then you know that you have a directed network. And that means that edges, so relationships that you are representing in your network, in your graph, have a direction. So you are representing one-way relationships. So the nodes in your network, the entities that you're studying, form a group where each node could be a source of the relationship or a target. Okay, so you have source nodes sending relationship towards target nodes. Okay, You can start thinking of some examples of relationship where you have a direction. Okay. All the examples that I'm going to use in these presentations, are based on social network data and relationships. But you can try to also translate it into, relationships offline or relationships that do not have to do with social network platforms. Okay, so this is, for instance, a representation of interactions within a Facebook group, and the edges here have arrows because they represent the relationship of commenting. All the nodes here are Facebook users. So we're looking at a Facebook group where people post messages, another may reply or comment. Okay, so what we are representing here is user commenting on other users. Okay, so we have source nodes, which are Facebook users, commenting on target nodes or other users. Okay, so there is a direction in the relationship. You might have seen graphs like this one representing retweet networks. In this case, source users or source nodes are Twitter users retweeting other users. Okay, retweet networks are very common in Twitter studies, extremely common in Twitter research. And one of the reasons is because it's kind of easy to represent retweet networks. And we're going to see later. And at the same time, while being rather easy, you could say quite a bit by looking at retweet networks. Okay, and we'll see it later. Okay, undirected networks are those where your edge doesn't have any arrow because the relationship is two-way. It's an equal relationship. You don't have a source node sending a relationship towards target node. This is an equal, kind of egalitarian relationship. Both nodes are at the same level, and it's a two-way, reciprocal relationship. Okay, so no arrow in the graph. Now, I think undirected networks are less common, but they're still relevant in social media research. And an example of it is when you are shown hashtag networks or co-hashtag networks. So for instance, in this graph, all the nodes are hashtags, and edges represent a relationship between hashtags, meaning that that relationship is generated when two hashtags are used together. Okay, so the presence of an edge between two hashtags means that those two hashtags were used together at least once in a conversation. Okay, think of it as a network representing the use of hashtags within a specific conversation, for instance, within a specific hashtag. Okay, so if you look at the representation of this relationship, you have hashtag 1 used together with hashtag 2. Okay, this is undirected. As I said, I think it's less common to see undirected networks, but you do see them in cases like this one. For instance, in hashtag analysis. Then we have one-mode networks. All the networks that we have seen so far were populated by one entity. So first we looked at nodes in a Facebook conversational network. So we look at the Facebook group, and all the nodes in our network were users, Facebook users. And then we looked at retweet networks, and again, all the nodes in those networks were Twitter users. Okay, and then we looked at a co-hashtag network, and all the nodes in that network were hashtags. Okay, so you have only one entity, either Facebook users in the first one, Twitter users in the second one, and hashtags in the third one. Okay, but you may also have some graphs where you see that you have two different entities, and these are called two-mode networks. In two-mode networks, the nodes are of two different types. Let's try to think of an example. For instance, if you want to represent a Facebook group and the interactions happening within a Facebook group, you might want to have to focus on both the type of posts, so the posts within the Facebook group, and the users. So you might have a graph where some of the nodes are posts and some of the nodes are users. And you may want to represent users commenting on specific posts, as I did in this graph. So in this graph, for instance, you have red nodes, which are Facebook posts, okay, the messages posted on the wall, let's say the wall of a Facebook group. And then we wanted to represent the users commenting on those specific posts. Okay, so an edge here is showing when a user, blue node, engaged or commented on a specific post, so a red target node. Okay, so different entities in a two-mode networks may be represented with different colors or with different shapes. So if we think back of the sociogram that we looked at the beginning, in a way, in that study, Moreno was trying to distinguish the members of the class as two different entities to a certain extent. Okay, so entity female and entity male. So you can see that way, or you can see that as an attribute of your entities. Okay, so the last bit that I want to cover is that of network measures, because we are going to use them, and also because network measures are very common in our everyday life. We just don't realize it, or we are not aware of it. So whenever you do a Google search, for instance, and you put a string on a search box, and then you get results. These results are ranked. Of course, there is some personalization, so they are ranked based on your previous choice. Your previous choices when you use Google, or the previous pages that you visited in the past, but they're also based on a specific network centrality measure. Okay, and we'll see it today. This is called degree centrality, actually in degree centrality. So network measures are very much used in ranking systems. We just don't really think about it. Okay, so you can remember that we're just going to see a few network measures, the most common ones, but there are many more in social network analysis. Okay, so very simply put, a node's degree centrality indicates the total number of edges touching that node. Okay, so now I want you back with me for a minute, because I'm going to ask you a few things. So if you look at the node A in this graph, what's the degree centrality of the node A? What's A's degree centrality? Okay. Oh, someone. 4. Let me see. 1, 2, 3. Is it 4? It's 5. Okay. You just need to count how many edges are around A. 5. Okay. And then if we say G is here. How many edges do we have here? 3. Okay. Okay. Perfect. Now, let's make it just slightly more complicated, but not much. When you have a directed network like this one, so you have edges with arrows, so one-way relationships, then you can also distinguish between in degree and out degree. In degree centrality indicates how many edges a node receives. So how often it is a target node. Okay, how many I receive, how many edges are pointing at me. Out degree centrality indicates how many edges go out from a node. Okay, so how many edges I send out, how often I am a source node I'm sending out. Okay, so if we go back to our graph, what's is in degree, in degree. One, perfect, okay, and is out degree. Okay, still one. And let's look at F. What's F out degree? Okay, perfect. Okay, so pretty straightforward, isn't it? I mean, the basic social network analysis measures, kind of straightforward. Okay, now the very last type of centrality measure that I wanted to show is that of Newman's modularity. And I think it's quite interesting because, again, we see it very often in any network graph, but you will very rarely see it spelled out for what it is. This measure identifies clusters or subgroups within a network. And these clusters, these subgroups, are identified based on how tightly connected to each other the nodes are within the network. Okay, so it's again, it's kind of straightforward to think about it. If you have a group of people, think of a class again, think of a class you have attended in person, for instance, and when you get out of that class, you will see people like connecting in small groups, right? You will see kind of cliques, you will see very close friends connecting together, and so you will see different groups forming from the bigger group of the class. Okay. So those within the tight group are very heavily connected. They have strong relationships, and they do not have strong relationships with those that are in another group. Okay, even though they belong to the wider group of the class. Okay. So you can think of it also in a platform kind of context, in a Facebook group. Anyway, you will have some communities probably forming where people connect to one another much more than others based on their specific interests or their life or their stories. If you think of it in terms of, for instance, co-hashtag networks, that might help if you look at modularity. So if you look at how hashtags are used together, you might find in a conversations, you might find certain thematic areas depending on how hashtags are used together. Okay, and we will see an example of it in a minute. So this is a representation of modularity. Here we have three kind of tightly connected subnetworks within the network. And then we have the gray nodes that are kind of loosely connected within the network, but they do not belong to any strong clique, okay, or cluster. I wanted to show you a few examples of studies where we could use these different measures. Someone is posting. In terms of semantic, could you use this in policy document data across different case studies? I guess you could. If you look at semantic network analysis, that is something that is very often used. So Alexandra, if you search for studies using semantic network analysis, you will see that you can do that. And in that case, you look at relationships between words. So what words are most often used together in a policy document? And this has been used, for instance, in speeches. I wouldn't be surprised to see a semantic network analysis of Obama's speeches as opposed to other, presidents of the United States, but I've seen it done on social network data as well, social media data as well. Okay. So I'll give you a few examples of studies where these different measures can be used. Okay, in degree centrality, usually we're interested in influence or popularity. Okay, we want to see how often someone is receiving kind of edges, relationships from others. This was a study that we did, a pilot we did with students in the MA Digital Media and Society on a Facebook group page. It was about Stranger Things, a very popular TV series. And the question, the research question, the basic research question may be, what is the most popular content within this Facebook group. So you see that we still have the red nodes that indicate the post within the group, so the messages posted in the group. The blue nodes are the users commenting or engaging, commenting on or engaging with these messages. And the size of the node here indicates is based on the degree centrality of the red nodes. Okay, the bigger the node, the most popular that content, that message was. So the most engagement receives from users. Okay. Same here, but with a retweet network. Now, we don't have much time to go through the whole example, but if you're interested, you can have a look at my paper where I was using this retweet network. What I would like you to remember is that in retweet network, in degree centrality measure can be used to see which Twitter users are retweeted the most, for instance, in a hashtag conversation. Okay, so in this case, the bigger the node, the most often it was retweeted. So it was influential in the conversation. In some studies, you will see that the label gatekeeping is used. So the bigger the node, the most gatekeeping power it has, because it means that the content posted by this node gets a lot of visibility and becomes most visible on the platform. Out degree centrality measures to me are slightly less interesting, but they show activity levels, so how often someone is engaging with someone else. So in the same Stranger Things graph, you can show which users, blue nodes, have been writing, commenting, or engaging the most on the group. Okay, so the bigger nodes are those users commenting a lot on the messages posted on the group. And the very small blue nodes might have commented once only. So are those who are not extremely active in commenting or engaging. Studies using degree centrality measures are similar to those, for instance, that Alexandra was mentioning. We can apply degree centrality measures in semantic network analysis, or for instance, in co-hashtag networks. So as we said, co-hashtag networks are undirected networks, and that's where degree centrality is probably most often used. And you may want to use it to see which words, in this case, which hashtags are most often associated. And again, if you want to have a look at this study, you can have a look at my paper, which is in the reference list. So you use, in this case, the size of the nodes represent degree centrality. So how often a hashtag was used with another hashtag, okay? Modularity, and then we'll have a break. As we said, modularity is very much about identifying clusters within a network. So for instance, this is the same study on Stranger Things. Our research question here could be, are users interacting in clusters within the group, forming subgroups? And the different colors indicate the different kind of communities forming in the group. So the color of the node here indicates the community, the sub-community, the clique. And in terms of semantic networks, this is a co-hashtag network of hashtags used on Tumblr, which is another social media platform. And if you use modularity, again, in a co-hashtag network, that might help you identify semantic clusters. In this case, I was looking for content posted on the platform with the hashtag BRCA, which indicates a health condition. And I wanted to see which other hashtags are used by users mentioning this hashtag, okay? What you see there represents different kind of thematic clusters emerging when people talk about this condition and use different hashtags, okay? So the green one, for instance, is very much about resources, so information sources and books and narrative that talks about this health condition. And then the blue one is more about advocacy around this condition. And then if you look at the other colors, you will find other themes, okay? We can start just having a look at these very short Twitter threads, which is kind of interesting, and I think it shows you some of the things that you can do on Gephi using a network analysis measures. And some of the conclusions, or some of them are more speculations, I think, but some of the conclusions, solid conclusions that you can make, and some of the speculations that you can also draw and raise. Okay. This is as I said, it's a Twitter thread. So if you click on the link on the slide, once you access the slides, you can open the thread. I'm just going to do it now. This is my Mark Owen Jones, who is an academic at, I don't remember if it's Durham University, anyway, in the UK. And he often, if you start following him on Twitter, you see that he often just shares very quick analysis that he does with Twitter data, sometimes even small data sets or bigger data sets. I just wanted to have a quick look with you at this thread from November, which I found quite interesting, and it's kind of brief but very meaningful. And it shows you what some of the things that you can do. So it focused on the use of the do not comply hashtag on Twitter. It was November. And he says this trend, so this hashtag was launched on Twitter in response to the UK's regulations related to the Omicron emergence. Okay. So we're mainly talking about mask mandate, I think, coming back as a response to Omicron. Okay. So this hashtag was very much launched to oppose the mandate, the mask mandate. Okay. So what he did was he collected data from Twitter mentioning this hashtag. Okay. So he scraped or collected data from Twitter where users were mentioning this hashtag. Again, we are not going to spend time on data collection. I'm just going to mention a few things about data collection later, but Warren's workshop later in March will do a bit more about data collection from Twitter. What you need to know here is just the this graph is representing Twitter users, so nodes are Twitter users mentioning the do not comply hashtag, and the edges here represent their interactions. It doesn't spell it out, but I think that the interactions represented by these edges are retweets. Okay, so here he explains this is based on a data set of 17,500 tweets that mention they do not comply. And these tweets cover 24 hours. Okay, so 24 hours of Twitter content mentioning the do not comply hashtag. So he did a network analysis to determine a few things. Most importantly, he wanted to identify the most influential proponents of the do not comply hashtag. Again, he doesn't spell it out, but I very much think that he's measuring influence based on retweeting dynamics, which is what most people do. So you look at those users using these hashtags that are retweeted the most or mentioned the most. Okay, retweeted the most. So we are looking at in degree measure. Okay, I am retweeted, so I receive retweets. So I am the target of retweets. Okay, so I become influent in this conversation with this hashtag because I am retweeted a lot. Whatever I say gets a lot of visibility. Okay, so the colors here, what do you think the colors represent? How do you think? Use Gephi to do this. What do you think the colors may represent? Bearing in mind what we said in the previous part of the session. I very much think you use a specific network measure to assign these colors. So these colors are based on something. Different groups, right? Yumeng says modularity. Yes. CG Wang says themes. I don't think so, because it didn't really map the themes. He mapped retweeting dynamics. So who was retweeting whom? He didn't do an analysis of the content of the tweets. He did an analysis of the relationships. So the nodes that you see here, yes, subgroups. The nodes that you see here are users, okay? It's not words, it's not hashtags, it's users. Each individual node is a user, is a person. A Twitter account, then we never know if it's a person or a bot. It's a Twitter account, okay? The edges represent retweeting or mentioning. So a Twitter account mentioning another Twitter account or retweeting another Twitter account. The colors look at how tightly connected are users within the overall conversation. So how often they interact with one another. So this is based on modularity, as Yumeng was mentioning, which means that all the, let's say, blue, light blue at the bottom left of your graph tend to retweet each other, mention each other very much, okay? They are very tightly connected. They are the subgroup, they are the clique, the cluster. So think of the class. We leave a lecture, we are outside, we connect a lot with our close friends because we have things in common, because we want to stay together. So while at the beginning we had just users using the hashtag do not comply or pupils within the class, as soon as these users can connect with one another, so can leave the room and start connecting the way they want, they form subgroups. So these colors are based on modularity. They basically show you, out of all the people using these hashtags, how they retweeted each other, how they connected to each other while using this hashtag. So how they retweeted each other, okay? Oh, sorry, what have I done? Just a second. I'm going to share the Twitter thread now, otherwise you don't see what I'm saying. Sorry. Okay. Here it is. Okay. So here we are. So it basically identifies two main areas in the graph. It's like two big groups. So there is on the right hand side, it's merely, then it goes to see who these people are, and it goes to see the content of their messages, and it sees that on the right hand side is mainly users using the do not comply hashtag to say do not comply to the new mandates, the new regulation, do not follow them, they're wrong, you shouldn't do it. And then he looked at the users, went up in the left corner of this graph, and he looked at the messages that they posted with these hashtags. And he sees that the content of these messages have opposite direction. They are very much about, no, we have to comply. It's important that we do wear masks. So they are against the idea of the hashtag. Okay, so he finds polarizations, and this network. Yeah. Did anybody put the microphone on? No. Okay, sorry, I'll go to the question that Yumeng was asking. May I ask how to identify the retweet meaning, e.g. users wish comply attitude? Okay, it's a good question, Yumeng. So once you have a representation like this, you've simply represented relationships of retweeting. So who is retweeting whom in the conversation where people are using this hashtag? Once you have that, you need to make sense of what you have. So if you read what Mark Owen did, is basically you go to your data set and you read the content of these tweets. That's the first thing you can do. Okay, you identify who is here. You try to identify the users who are most prominent here, so those who have highest level of retweets. and and go and see who they are and what they write. And that will help you try and understand why these people are so tightly connected. Okay. And if you go down the thread, so basically it goes and reads who these users are, especially the most influential ones. So those with very high integrity, those who are retweeted a lot. He reads his bios, he reads his content, and you start seeing that most of them are people who are supporting these hashtags, people who say, no, we shouldn't comply, this doesn't make sense. Okay. And then on the opposite side, he does the same. He sees what accounts are there. He identifies the most influential accounts, so those who get the highest numbers of retweets, and he goes and reads their bios, try and understand who they are, okay, to make more conclusions. Here is just a representation, and then he tries to understand more about those Twitter accounts that are represented in this network and why these networks have these polarizations, this very strong polarization. Okay, so if you go down in the thread, he does exactly that. So he starts focusing on this purple side of the network, and he tries to identify the users who are most influential. So those who are retweeted most than anybody else. And he understands, he sees that we have this account here, Lots of Fox, who is a rather well-known individual, especially in the context of anti-lockdown protest, anti-mandate protest. Okay, if you check his account, you'll see what I mean. Okay, so what does he do? Okay, he sees this is the one getting most of the retweets in this part of the network, and he checks his bio and what he says in his tweets. Okay, and this guy says he does not wish to comply. He endorses mass civil disobedience. As I said, this is one of the forefront of the anti-lockdown protest in the UK. Okay, and that's a comment by Mark Owen. He says he also seems mad, but okay. So what you need to do once you have a graph, you need to try and understand who these nodes are, especially the most influential ones. Okay. And then so it starts from the one with the highest number of retweets, and then it goes down. Okay. And look at the other, he calls them influencers. I've called them gatekeepers in the presentation. Okay. So look at the others. And he says a lot of the influential accounts also are kind of anonymous, which is obviously suspicious. So he says there might be some, bot accounts, or there might be some coordination here. Not all of these accounts seem real or are human, directed by human beings. There might be some trolling or some bot accounts as well. Okay, so he spends some time on the data and tries to identify who these users are, especially the most influential ones. Okay, and then he goes to the other side of the network, the blue side. So, okay, we just look at this side, those who are against the mandate. Okay, and we see that we have especially accounts that we know have always been anti-lockdown measures. Okay. And then now it focuses on the other side, the blue side, to try and see who is on the other side of the spectrum. Okay, and here we are. The most influential accounts pushing back against the hashtag. So those who say, no, it is important that we comply because COVID is real and vaccines are important and masks are important. And some of them are parody accounts. For instance, there is the Boris Johnson's parody account, which is very prolific on Twitter and sometimes also rather funny. But anyway, it's mocking the prime minister. Others are pro, the others are more plainly pro mask wearing, okay? And he says this polarization seems to have a political dimension. So he says it's partisan. And what does it do to make that conclusion? He looks at the bios. So he looks at the information of these influential users on both sides of the network, okay? So he sees that those promoting that hashtags seem to be mostly right-wing nationalists. So there will be also, you know, kind of US-based accounts, so like Trump, MAGA, so Make America Great Again, which was Trump's slogan, conservative, God country. How does it do that? Well, it takes the bios of those accounts and it does a very basic text mining. So it puts them in a text mining software and it sees which words are most frequently used in these bios. Okay. You could use a word cloud to show it, but it's pretty, you know, you take all those bios and you put them in a very basic text mining tool, and you just see which words are most frequently mentioned in those bios. And it sees certain words that are very, very common in kind of right-wing rhetoric or narratives. Okay. And then it does the same for the bios of the influential users on the other side. And you find words like Black Lives Matter, which are openly kind of more left-wing, okay? Johnson's out, socialist. So you see that the type of words used in the accounts, in the bios of these accounts, seem to show a very, very strong political polarization. And so it adds this information on the graph. Okay, so in a nutshell, I would say this is very similar to what, or very close to what, who was it who asked the question? Hamed was asking. Okay, it's very much about identifying influential users in a hashtag conversation and try to make sense of what's happening in this conversation around these influential users. Okay, now we're going to try and do something similar, and I'm going to show you how to do it using Gephi. So we're going to try and do something like a graph somehow similar to what Mark Owen did here with the do not comply hashtags. Okay, we're just going to focus on a slightly different topic, not so different in the end, but we're going to do something similar using Gephi. Okay, so okay, now you're seeing my screen. So this is the whole folder for the workshop. We have just done part 1. Now we're going to do part 2 on Gephi. Okay, now now either you have 2 options. You can just look at what I'm doing, because each individual step is within this handout, and it's probably the best if you just look at what I'm doing, and then later you try to do it with Gephi. The other option is if you already have Gephi on your machine, you can try and do what I'm doing. Okay, the time is a bit limited, so I think it would be best for you to just look at what I'm doing, and then you can try to replicate it by just using this document. Every step is detailed in the document. Okay, you just need to have Gephi on your laptop, whether it's a Mac or Windows-based laptop. Gephi works with both. Okay, so this is the kind of project that we're going to look at. So we're trying to use Gephi as a software to design a graph that represents interactions on Twitter. We have an hypothetical project. We want to investigate how English-speaking Twitter users are discussing the COVID-19 vaccine. Okay, this is based on a data set that I downloaded a few months ago, actually. Okay. We have a specific initial research question, which is along the lines of which users are key sources of information, so gatekeepers, in content discussing the COVID-19 vaccine in the English-speaking Twitter. Okay, so we want to see the key sources of information, and maybe once we see who these key sources of information are, we can make some considerations on any political leaning in the conversation or any attributes of the conversation based on the interactions that we see in the network. Okay. So to address this question, we're going to map retweeting dynamics, very much like Mark Owen did in that graph, okay, that we just looked at. So we are going to do a social network analysis of user interactions via retweeting. So we're going to look at which users retweets which users. The first, so section 1 of this document briefly tells you how I extracted the data from Twitter. I used a tool called Tags, and anybody can use it. It's based on Google Spreadsheet, and it's very user-friendly. It has been there for years now, and it has become extremely user-friendly. And you can download, you can collect data from Twitter, either in a kind of one-off data collection, and then in that case, it will collect data up to, I think, 3,000 tweets, or you can leave it going for a live data collection. It will keep on collecting data for hours or days. Now, depending on what you want to collect, it might stop. If it's something that is extremely, if you use hashtags that are extremely popular, you will only be able to collect a fraction of the tweets because there is a limit to the number of items that can be collected through an API. But it's pretty good to use it if you have a project that is on a specific conversation on Twitter, okay? What you see here is the specific search items or filters that I use to collect data. I basically collected tweets mentioning the word COVID and either vaccinations or vaccine or vax or jab, and in English language. I left it on for an hour. Yes, so we have 1 hour of content posted on Twitter on the 19th of October 2021, not 22 obviously, mentioning COVID in combination with vaccination or vaccine or vax or jab in English language, okay? What we want to do is to see who retweeted whom in the data set. So I'm just going, I've already done it, and we're starting from point 2, okay? The data set I'm going to use is the one that you see in the folder, okay? So if you want to replicate any of these steps, you can simply download the data set from the Google folder. Okay, so now I'm just going to open the dataset from my computer because it's easier for me, so that we can have a look at what you see in the output that you get from tags. This is very similar to any output that you will generate from almost any tool used to collect data from Twitter. Okay. Some of the metadata, so the additional information that you get, might have a slightly different position on the spreadsheet, but the content, the type of information is going to be very similar, whatever tool you're going to use. Now, this data set has, let me just go, this is the original data set. Let me just do one thing. Sorry, okay. This is the data set, the full data set, and I think it has around 9,000 tweets, okay? Now, let's look at each row of the spreadsheet. This is an Excel spreadsheet, and the first column is IDs. So every, first I should say, every row is a tweet, information about one tweet. The first column gives you an ID for that specific tweet. And then you have all the useful information. So you have the tweet author, the content of the tweet, the timestamp, so when the tweet was created, generated, specific time, then additional information, and the URL of the tweet, location, when it's available, the number of followers that user has, and so on and so forth. Okay. So each line, each row is a different tweet. And in each column, you get specific bits of information, either data or metadata. Metadata means additional information that you have about that specific item, so that specific tweet. Okay. Now, you see that when a tweet is a retweet, the text, the content starts with RT, which means that this is the retweet. Okay. We have quite a lot of retweets, which is very, very common in Twitter content, as you will have seen in any study about Twitter, okay? What I have already done is to generate a spreadsheet where I only have the retweets of this data set. I'm not going to show you how I did it now because we don't have time, but you have the explanation on the handout, so you can do it on your own. Just know that this spreadsheet only contains retweets. So each line here is a retweet. Okay. Now, what we want to do is to show retweeting dynamics. So who is retweeting whom in this conversation, talking about the COVID vaccine? And we want to map these relationships. So we have a direct network with people, users, accounts retweeting other accounts. To import the data on Gephi to generate a graph, you need to import nodes. In our case, the nodes are the accounts, okay? And the relationship that we are representing are retweeting relationships. So accounts retweeting other accounts. So the source nodes are accounts, Twitter accounts, and the target nodes are other Twitter accounts. Now, the nice thing is that we already have source nodes. The source nodes in this spreadsheet are the authors of the retweets. So we know that this first user, for instance, has been retweeting this user here, right? Every retweet starts with the name of the account being retweeted. So to be able to import data on Gephi, we need to have all source nodes and target nodes. We already have all the source nodes. What we need to do is to extract the target nodes that we see here, okay? So these accounts that are here. To do that, we can use a function from Excel. So I'm just going to copy the content of this column here, and I'm going to paste it to the right of my spreadsheet so that it's going to be easier to work on it. Now, I usually keep all the data on the spreadsheet, but if you find it easier, you can also delete part of the metadata that you don't need so that you don't have so many columns in your spreadsheet, okay? Now, as I said, we need to isolate these names here because these are the targets of the relationships that we're mapping. And to do that, we can use a function on Excel. So you select this column, as I've just done. You click on data, and then you click on text to column. Now you leave the information as it is as delimited, click on next, and you click on space. So basically this is going to split the content word by word, which is what we want, because in the second column that you see here, we have exactly the accounts that we need to isolate, right? I will click on next and on finished. So now you see the tweets have been split word by word, and what we are interested in is these accounts. Okay, did anybody have any questions? Because I heard a microphone coming up. No? No, okay, sorry for the crazy screen. I'm going back to spreadsheet. Okay, so now we have our target nodes. So the nodes that were retweeted, right? And here we have the nodes who retweeted. So the source nodes are here and the target nodes are at the end of the spreadsheet. Now we have to take this information and put it on a different spreadsheet, okay? So I'm just gonna copy this column. I'm going to open a new spreadsheet and I'm going to paste it, okay? So these are all my source nodes, and to import this data on Gephi, remember that you need to call this column as source. Now we need to put our target nodes in this column, so I'm going back to my original spreadsheet. And I'm going to copy my column. Where is it? Here it is. Okay. I'm going to copy this column and paste it here. Okay. And this is called target. Now I have a very nice and tidy spreadsheet where I have all my source nodes and all my target nodes. So I know that these, Selax also retweeted these, Foster, and then El Buffalo retweeted ECM, and so on and so forth. So these are basically representing all the edges in my data set. So who retweeted whom in my data set? And this is exactly what I need to start using Gephi and represent these relationships in the form of a network graph. So you remember, you need to save this file as a CSV. So the CSV is a specific format. Let me just save it somewhere. I'll save it in the desktop. So you need to select the right extension here, which is CSV, not this one, but comma delimited. Okay, CSV comma delimited, and I'm going to call it edge list. So it's the list of edges in my data set. Now my file is ready. I can close everything. Do I want to save it? No. Well, I'll just leave it there. I'm going to launch Gephi now so that we start seeing how Gephi works. I have already installed it on my laptop. If you go to the website, Gephi website, you'll see that you can install it easily on your laptop or computer or machine. And there are also several tutorials that you can use. Now I'm going to, once you launch Gephi, you always get this window. So if you click on new project, you'll simply starting something new, okay? First of all, you need to import the data. So I'm going to data laboratory here. And we need to import a spreadsheet. So we need to import the edge list that we just saved. So I'm going to click on import spreadsheet. And this is exactly what we want to import. It's an edges table. So a table with all the edges that I want to represent. Remember to keep edges table selected, because if you click on nodes table, this is not going to work. Not stable when you have a table just with the nodes, okay? But we have the edges, so this is it. And then you need to select the file where the edges are, and I have it in my desktop. So edges, edge list vaccines was the one. So you see that it seems to be working okay. You have all your sources and all your targets here. So you can click on next, and you can click on finish. So now you have imported your data. You'll see that you have a little label here called nodes. This is the table of all the nodes in the data that you've imported, both the source nodes and the target nodes. If you click on edges, these are the edges. So you have your source nodes and your target nodes. The relationship is directed. We have a relationship. And here to the far right, you see that there is a weight. This is basically telling you how often this relationship happened. So one user might have retweeted another user more than once in the data set that you imported, right? So if the weight is more than one, it means that this retweeting happened more than once, maybe on different tweets. So I'm just going to, I've ordered it in descending order. So the weight, so where a retweet happened most often is at the top. So we know that, for instance, this Trump user retweeted Song Ping Pang 7 times. Okay. And here we know that Frederick Walk 2 retweeted the New York Times 6 times. Okay. Now let's see how the graph is looking like at the moment. I'm going to overview. Oh, this is what I have. And why is that? Because I have, in total, my graph has 7,302 nodes and over 6,000 edges. So you need to work on the layout of your graph to make it say something. You will see that here on Gephi you have a form called layout, and you can choose a layout. If you have many nodes in your network, I would recommend the only layout that actually does the trick is the force 2. So this is an algorithm that moves nodes in a way that you visualize relationships moving the nodes in the space. So I'm going to click on Force Atlas and I'm going to run it and I'm going to stop. So you see that the nodes have moved and we start seeing edges and nodes. The color is all black, so it doesn't help us very much, but we can change the color and we can start doing something with it. Okay, so now we're going to use some of the measures that we saw to change the layout and to visualize some of the dynamics that we want to visualize in our retweet network. Okay, first of all, I want to change the color of the nodes so that if I change the color, I will be able to distinguish better what's happening here. So the node, I'll distinguish the nodes from the edges. Now you see that there is an appearance box up here. I'm going to select nodes here because I want to change the color of the nodes, and the palette symbol here. I leave unique and I choose a different color. I usually choose red or blue, but you can choose whatever color you want. So you start seeing nodes a bit better. You see the color has changed. Now I want to start seeing which ones of the nodes are most influential in my network, which means which nodes are retweeted the most or most often. Okay. To do that, I need to run my in degree centrality. So I need to measure in degree centrality. Okay, so how often someone receives an edge in this network. So you see that to the right, you have a statistics box here. What you need to run is average weighted degree. This is going to give a value degree, in degree, and out degree values. And it's looking at the weight as well. So it's considering the weight of an edge as we looked at earlier. This is a report, okay? It doesn't really, you can look at it. So the horizontal axis is showing you the in degree value, in this case, the degree value. So the more you go to the right is the higher the degree. So the more edges are around that node. And the vertical axis is showing you how many nodes have that value of degree. So for instance, we know that very few nodes have very high degree. So it's probably one having around 280 degree. And many have very low degree values. And you can go down and see also in degree and out degree. Now, a way to look at this value is to go back to the data lab now, because you will see that if you look at the nodes table, you also have in degree, out degree, and degree values. Okay. What we are interested in is in degree, so the most influential nodes. So if you double click, it's going to be ordered in descending order. So you see that this node at the top has a very high in degree, which means that it has been retweeted 673 times. Okay. And we can look at who this account is, Occupy Democrats. Now, what would I do now? Going back to Yumeng's question, I go straight back to Twitter and see who this account is, what it represents. And the same for all the top people here. Who are they? Why are they so important? Is it because they have a lot of followers? Is it because they are public figures? Is it because they are organizations? Okay, that's what you need to do. Okay. Now we know that we have a number of accounts that seem to be extremely important, retweeted heavily in the network. How do we visualize it? Well, if we go back to our overview, we can change the size of our nodes in a way that it shows which ones are retweeted a lot, so most influential gatekeepers. To do that, you stay on nodes here and you click on the size shape. Okay. And now you need to tell the software that you want to change the size based on weighted in degree values. So those with little in degree has very low size. Those with big in degree, high in degree have a big size. And you apply it. And now you see that it's changing. Okay. A way to see it better is to go to preview, which is where your final image is going to be generating. Click on refresh. And this is getting closer to what we want. Okay. So we start seeing where the communities in a way are forming, and we can use modularity later to see that. Okay, so going back, I would like to give labels to these nodes that seem to be so influential. So if I go to data laboratory you see that my labels column is empty, but we do have all the labels of the nodes here. So you can simply copy the content of this column and paste it here. And to do that, you use copy data to other column. So you copy the data from ID and you paste it in label, okay? Now, if you go back to data laboratory to overview and you click on this one here, the labels are coming up, but of course they are not very nice because you have many, many labels, okay? You can change the size of the labels by clicking on the small button here. Here you have a label thing, and you can change the size of the labels based on the size of the nodes. So you see that now the big labels are those where you have nodes with high influence or high in degree. When you are on the preview screen, as I am now, remember that you need to refresh the button every time you change something. And you can rework on the visualization here for your final image. So if you want to show labels, it's here. But again, when you have so many labels, the best thing to do is to just keep the labels of the nodes that you want to show. Okay, so the most influential nodes, in this case, those who are retweeting the most. So I would go back to Data Lab and delete the content of the label column. Clear column actually, and clear the label, yes, and I will only use the label of the accounts that I want to visualize clearly in my graph. Now you could also put the names of the accounts straight away. I don't have time to double check what the name of the accounts is. I'll just use their handle for now, just to show you how it looks like. I'll just do 3 of them for now, so that you see how it looks like. Okay. So now, if you go to overview, and you see that I only have these 3 visualized with their labels. Okay. So we start seeing some of the dynamics, and we have visualized these ones. Now, the last thing that I really want to show you, you can change the color of the edges here. For instance, if I go to show edges, I go to color and I click on custom, I can change, it's usually gray. Okay. The last thing that I wanted to show you is the modularity, how I can use modularity. In your statistics box, you can also do the modularity measure. So here is going to identify communities in your network, okay? And to show this community, we can use colors, just like we saw in Mark Owen. So if we go back to appearance here and we go to the palette, we can use, we can tell the software to choose the modularity class to show different communities or clusters in my network. Okay, so under partition, I do modularity class. And here is basically telling you that it has identified different communities. One has 8.27% of the nodes, so it's the biggest community, it's going to be the purple one. And then the second one is 3.82% of the nodes in the network. Okay, so if I apply it, you see the different colors coming up. So now here it is. This is our retweet network. Okay, and we can see that we clearly have some very strong communities using in this conversation. Okay, so what I would do would be to go and look who these accounts are, what kind of text, what kind of tweets they post, and trying to understand why they are so influential, whether there is a political leaning in what I see in a conversation that, of course, is very highly partisan. The very last thing that I wanted to show you is how to basically get rid of nodes that are not extremely meaningful for what you want to show. You can use filtering options. Okay, let's see that I want to just show the key communities and I want to get rid of nodes that are not part of this community. I'm going to click on attributes and then on partition, and then on modularity class. So let's say that I only want to show nodes that are part of the top 3 or 4, let's say the 4 communities, and I filter, and this is what I see, which is basically what Mark Owen was doing in his one. Once you're here, you can try to visualize these nodes a bit better. Now you have a smaller number of nodes in your network, so you'll see that it will be slightly easier to use other algorithms to visualize your nodes better. For instance, if you use no overlap, you should be able to see nodes occupying a bit more space, so moving a little bit in the space. Now you need to realize that Gephi does take quite a bit of memory of your laptop, so it might be that it doesn't work with me now because I'm also video conferencing, but it's working. So depending on the memory of your computer, some operations may take time and some may not work well. Okay. If we go on preview now, you see that nodes are moved a little so that you can see them better. Individual nodes can be seen better. Okay. Okay, I think this is the key features these are the key features that I wanted to show you today. To extract this image, you just need to click on export and then select the format. Let's say that we want a PNG file, so an image file. And I'm just going to save it there. Like image Maxine. Once it is exported, of course, you can use it in any report. Okay. You can crop it, you can describe it. Now, if we go back to, I just very briefly wanted to take you back to the handout. You see that all these actions are described here, and I don't think you will find any issues. Do let me know if you do, if you get stuck with anything. We have used it also in the MA Digital Media and Society. I have extended some of the operations here, so you get a bit more, especially on modularity. But if you find any issues, do let me know. Drop me an email, and I'll look at what the issue is. I just wanted to take you to the bottom of this handout, because there are a few elements I want to add that are very important. First of all, ethics of social media research. Now, in any data that you're going to use in your thesis, any social media data, you need to be very careful with the information that you disclose. Check the ethical guidance, academic guidance on social media research ethics. Ask yourself, what do I need to disclose, even in my graph? Don't disclose Twitter handles of ordinary users. That's privacy. They would not expect anybody to be studying what they're doing. And certainly it wouldn't be ethical to disclose their Twitter handle with them not being aware of that, okay? So in your graph, just disclose Twitter handles of users who are public figures, organizations, actors that you know would expect for their information being extremely public, okay? Ask yourself about ethics, okay? If you use a graph in your report, explain each and every element in your graph, who the nodes are, what the edges represent, whether it's a directed or undirected network, what kind of measures you used, and especially what does the color or the size of the node and the edges represent. Everything needs to be clearly explained in any social network analysis graph. Interpret your finding. Don't leave your graph just there.